Hi everyone,
Hi Amos.
how are you?
Good.
Hello, Amos.
What we're going to do today, we are going to chapter 2, which is really, I would say it's the heart of this course. Chapter 1 was foundations and preparing us to really get to this one. And the beauty about chapter 2 is we have really a projects that taking us from A to Z, how you manage machine learning projects. By the way, if you followed what we did in chapter 1, in fact, we have gone through this process, and what we're going to do now is just really repeating in a different examples and more detail many topics we mentioned. So many topics were kind of buzzwords so far, and now we're going to kind of deep inside and really see how the process of machine learning are from A to Z. We're going to spend probably today and next week for this chapter, and if needed, we'll take some even a little more. But this is really the heart of this course, especially for the scope of this program, okay? So let's see, what do we have in a machine learning process? What are the steps? So they are right in front of us. There are 8 steps, usually, okay? And I will go over them, and then I will mention how we did it for the regressions we used in chapter 1, the examples I used, okay? And then we will take another example in this chapter and implement every step on that example, okay? So first of all, you really need to look at the big picture. By the way, I'm just going to kind of mention all of them, but then I'm going to dive deeper into each topic. Look at the bigger picture means understand the problem, understand what you really need to do. Then you need to get the data, okay? And I mentioned that you can get the data in many ways. I even showed you the example in the projects that we installed. We built up a special object. By the way, and I know that Moria mentioned that, and she was absolutely right. I'm not going to test you on the details of each functions here that I built for you. I strongly recommend you learn it, but I do require that you do understand what each functions here does, because the way I built those functions, they make a specific, they allow me to perform specific functions. For example, save a figure, it has to do with visualization, we'll get in a minute. So as far as code relate, I'm not going to overload you, especially in the exam, because I think it's a little harder for the scope of this course. But I do require that you do know what save figure does and the role of it in visualization, and I will mention others later on. But all those functions were structures according to those steps, okay? So some functions help me to get the data. So after I understand the pictures, I'm getting the data, and I will dive into that topic today, okay? Discover and visualize the data, okay? There is nothing better than look at the data. And frankly, I have gotten some data with some researcher that I'm doing a research for them, and I didn't have time, so I gave it to some of my assistants, and he told me he did something called imputation. I will mention that later on, how to deal with missing data. And I asked him if he removed some records that missing too much data. And he said yes, because I want to make sure that he removes very bad data before he does that step called imputation. Imputation is a method to fill data when there are missing data. He told me, yes, okay, I got the data. He ran the algorithm, blah, blah, blah. He got results. So I said, okay, send me the data. I want to look at it. I actually took the data, I looked at the data, and I noticed it did not remove bad records. So visualization is a very extremely important step, and I will go over that today as well, okay? So remember, there's nothing better than looking with your eyes on the data. Very important. Then, preparing the data for machine learning, we learn, data frame, we learned about NumPy, and many times you convert the data from Pandas data frame to NumPy array just because you want to use some algorithms, and those algorithms are written in such a way that you use only NumPy because it works much faster, and we can't afford to. I'm not going to kill you on that one. I know it's new, especially NumPy. I doubt you use Pandas, but I'm not going to kill you on that one, understanding that you came with a limited knowledge of Python. But if you ask me, take that one seriously. If you want to get a good job as a manager, I'm not talking about as a computer person, this knowledge will be very useful for you. Just another thing that I love to mention it over and over. Don't forget, I'm an economist, okay? I got into the computer science just because I know how important it is for me to implement things I do in economics and option trading. I teach corporate valuation, I teach business simulations. I write all those softwares by myself. Well, usually people don't do that, but thank God, that's what makes my other courses much different than usual courses. So I wanted to mention, I am, you're taking this machine learning course from a person that is an economist, okay, a CPA, a finance person. And that's just to emphasize the point that it's very important knowledge to acquire as a manager in any field you go to. Okay. Then we said, okay, we looked at the data, we prepared the data, and now we want to choose a model. If you remember, we did the same with the linear regression. We have some data, we put the data in a data frame, we looked at two. Let me just even remind you in the simulation. By the way, that's one you have on your desktop now after the installation. We got a plot of the data. That one we used data frame. We plot the data looks like linear, okay? Then we select linear model, we run that, and the results are in the bottom here. Whoever wants to follow, that's what we did last time. Then we ran that one to look at the data. We looked at some missing data. So we did plot the data. We understood that the model we should use should be a linear model. That's what we're doing now. This step is select the model. We use the linear model instead of polynomial or any of the other models that unfortunately we won't have enough time to go over them in detail, but I will mention a few of them. I won't dive into the mathematics, but at least I will explain what do they do. Like polynomial I mentioned last time. A polynomial definitely will not do the job. We even show that it might even do an overfitting, a concept we talked about last time. And a linear model, it's what seems reasonable for this simple problem. So we want to use a simple model. Okay, we chose the model. And then, by the way, don't get confused between fine-tuning your model to training your model. By the way, if you notice in 5, after we select the model, we train the model. What does it mean to train? Let's go back to the previous example, okay? If I looked at, hold a second, I want one before. Okay, we said, okay, we decided the linear model, that means pulling a line, but which line should I use? So that's what means training the model. Training means I'm going to find the parameters of a linear function. Linear function has two parameters. One, where the line is starting and what is the slope of the line. So I'm trying to find a line that starts from a point and has the slope such that the points will be as close as possible to the line. By the way, I just introduced another concept, which means what is the criteria to find the best line, okay? So when we're training the model, we're trying to find the best parameters for the model such that it will fulfill what we're going to call as a performance measure. I mentioned that last time. Now we're going to dive into that deeper. I just want to show that all those examples we used really had already all the foundation in a machine learning process. And now we can start using professional vocabulary, okay? So fitting or training the model means finding the best parameters of the model such that we get the best performance measure to be the best. If the performance measure is that the point will be as close as possible, that means that the total distance will be as minimum as possible. That's my performance measure when I train a linear model, okay? That was the next part. And we're going to use today on a different database, and we're going to talk about the whole process all over again on a different example. Okay, then I want to present my solution. Here we go. In fact, I gave you a framework. Here I am. And in fact, I'm presenting it as a web application. This one is really a web application ready to be uploaded to the Moodle. To the Amazon Web Services, Google services, whatever. You can deploy it as really a web application. After you run the data, somebody can look at it and everybody can go online. So presentation is very important. If you remember in the previous course, Business Intelligence, we said presentation layer and business intelligence. And if you remember my comment, I said, you know, if you ask my opinion, there is no place to put presentation layer and Power BI. That's why I didn't spend too much time in that course. The best presentation layer should be online application, okay? Another example you already know. What is everything that I do in Academy City? It's all web application. I present simulation, I present, let me just present that one for a minute. Won't take much time. Presentation is extremely important. Let me go to a course you have never seen, and I'm teaching this course. So this course, corporate valuation, I have a simulation. So how am I going to present my simulation to a student or to anybody or in investment banking? Okay, here we go. It's a web presentation. Everything's here. It's not Power BI. This is really done from scratch. Let's use Amazon. Okay, the amazing part of that, sorry. This one is a web presentation. So if I go Amazon, okay, which country it is? United States. This is a presentation layer. This is will be almost impossible, by the way, to do with Power BI. No way, because it's not designed as a simulation or as a software. So here is the beauty. I did all my work. I built the whole system that does valuation. It pushes the data from the SEC automatically. It does the valuation automatically. By the way, it's missing, I didn't choose here. I need to choose the industry. I will just choose one of them, doesn't matter. And then I get the whole valuation done. Moreover, I want the student or the investor to do, this is, by the way, a machine learning already. This is really, we will learn later on. I will give it as another example. What is the distribution of my valuation? That's an example of presentation. There's no way to do it with Power BI or any other. You have to build your presentation. Many people think, oh, I'm just doing the algorithm. I don't really care. Let somebody else do. Take my word for it. Those people don't survive too long. Okay? You have to know how to present. How do we use it in this course, the presentation layer? By the way, we really actually make a picture, and inside here, we just bring the picture on. And I demonstrated it last time, and I will demonstrate it again today. Okay, so how did we present the solution? We simply draw the line on the regression, and this is really our solution. So I can say, look at that. By the way, it could be really nice if I added what is the Q. In fact, you can see that it's like about 5. It's starting from, that's the Q0, and the slope, whatever it is, I should probably write it down here or leave it to you as an exercise, how to add. You can just go see how I did it in the code here and just put it here as well. It could be a better presentation. Okay, let's move on. Finally, launch, monitor, and maintain your system. As I said, you're uploading it, let's say, to Amazon Web Services, people commenting. They said, well, you should change this one, you change this one, blah, blah, blah. And that's what you're supposed to do, finally. And then it's really start getting his own life. Let's take as an example, let's say you're writing some algorithm that can help a sales representative to sell a product. You're writing him an algorithm that shows the relationship between the attributes of a customer and specific products you want to recommend. Okay, that's a machine learning exercise. Okay, you develop the whole things. The next things you want to integrate it inside a CMS application. CMS is Customer Relationship Management, or another word, it's an applications in which you give services to your customers. Customers can look at stuff, you can assist them, you collect data about them, and then the algorithm will be embedded inside the CMS. Now, as customers use the system, you get a feedback, and then you monitor and you modify according to what the customers mention. So that's the last part. Frankly, each step on the way, it's extremely important. You know, look at the big picture, seems like a trivial one. Take my word for it, extremely important. I will highlight that in a new example. Questions so far before I start a new example?
No, I think we're good.
Good, thank you. Eduardo?
Yes, I'm doing good. Yes, yes.
Good.
Yeah, I'm fine.
Very good. Rafael? Good, good. Just to see your faces a little bit, you know? That's it. And good to see you guys. Eduardo, how you doing? You put a new picture on the background.
Yeah, you like it almost?
Yeah, of course. I like to see you better than the picture, to be honest with you. So I think you should put a little less distractive.
Well, less
So
distracting
the
picture.
focus will be on you and not on the picture. Anyway,
Okay,
let me move on. Good to see you guys. Okay, so we're starting from scratch. We have a challenge. By the way, you can look at it as here there are examples. If you really want to do projects, I'm afraid to give you this one as a project because I leave it too hard, in my opinion, to the scope of this course to challenge those one. But the brave of you can really take one of those. I will even consider it as the projects for this course. I want mine. I'll give you something a little easier. In a couple of weeks, we already will be in a level that I can give you the assignment, okay? And I will lead you and help you to do it. Okay, we're getting an example in which we're gonna explore, okay? Or we're gonna understand the pricing of houses in different districts in California. Okay, by the way, this one is, you have the example, I will get back to that, okay, to show you how we actually paint this one. The only things you take here is really the picture of California, and all those dots are marked by data that you have. So I'll get back to this picture. But defining the problem is we want to understand, okay, what leads to higher prices of houses in different districts. So every dot here, it's like a district in California, and we would like to understand what lead those prices, why. If I'm working in an investment or real estate company, and we want to know where to invest, it would be very interesting to know what lead the prices. Maybe we can find a new district that have very good attributes that lead to the conclusion that prices should go up. And then we can go there and just invest there, and then over time make a lot of money. Okay, so you are being asked, please develop a machine learning process, develop algorithms, use algorithms, and tell us what can you, which places you think the prices are high, prices are low, prices should be more than they are, blah, blah, blah. Okay? That's the general. So look now at the big picture. And what do we want to do, as I mentioned before? But now you want to be really more specific, because so far I was saying a lot of things that seems clear, but when you're doing projects of machine learning, you really want to be knowing what is your product going to be used for. What do I mean by that? If I give you a system that can explain the prices in different districts, what is my company going to use my algorithm for? Okay? So the first thing you're going to do, you're going to go and ask your boss, and I highlighted, by the way. I tried to do that. I think it will make you focus on the key point. So I highlighted what exactly is business objective of my study. And moreover, how does the company expect to use and benefit from this model? So if I know how to handle and do my machine learning algorithm. So if I know that this is going to be as part of a bigger process, I might go and ask more questions, okay? One of the things that I might even repeat it later on, you know, you're asking me to predict what the price is supposed to be in a specific district. How are you going to use my information? Do you really need the exact prediction of the price? Or is that will be good enough if I tell you 4 or 5 categories? For example, cheap housing, medium price, average price, medium, upper, mid-upper prices, and very high prices. Is that enough for you that I will give you a model that can predict the category that the housing price going to be in that specific district? Or do you really want me to give you a specific number? That makes a big difference. Anybody wants to help? Why? Remember of 2 types of models we have seen in chapter 1. Okay, let me remind you if you don't remember. We talked about categorical and we talked about regression. Remember? Anybody? Volunteer? Say yes or no? Yeah, remember? Anybody want to guess, is this problem, should I ask that question or I shouldn't? I think I should, don't you think? Because if it's a regression, I might use a different type of regression, maybe even polynomial regression, SVM I will mention in the future. I will mention random forest. There's many algorithms that deal with predicting specific number. But if I'm talking about categorical, I might use totally different algorithm. I might use neural network. And in the neural network, I will define categories. I might use an algorithm called logistic. A lot of people, unfortunately, there's many PhD students or even doctors that didn't really improve, that moved away from logistic regression. And many of them still use logistic regression for categorical. It's a good algorithm, but there's much better tools today. Neural network, you know, can do implicitly even logistic regression if it finds that it's a better one. But all those concepts, I assume that you probably never heard before, but I will repeat them and explain some of them as we go along. Neural network is a very important concept. You know, logistic regression, less important, but think about it as a regression that try to predict category instead of predicting a specific number. Chapter 1, we talked about regression, that we try to fit a line. And if I want to predict, if I have a higher income per capita, what should be my life satisfactions, I gave a number. That was a regression. But if I want to make categories of happiness, unhappy, medium happy, and very happy, that will be logistic regression, okay? When the dependent variable or the variable I'm trying to explain is categorical, the problem becomes to be a category problem, and I need to use categories. If it is estimating a specific number, it is in the category of regression, okay? So that will be very important. So that's a question I must ask before I even start thinking about which model I should use specifically. But at least I know if it's a categorical or regression. So I need to go and ask those questions before I go. This one, I'm not going to go over that now. I will get back to this. What is pipelines? It's a technical topic. How to do very efficiently, how to run an algorithm in machine learning. I will leave it for now, and I will get back to that later on, okay? When I will actually implement, I think it will be good to demonstrate. I'm not going to ask you how to implement pipelines, but in the exam, I might ask you what pipeline is being used for, okay? I'm not going to ask you how to implement it. It's a little too hard. I have it already. You have it in your code that I gave you. And if you really want to learn it, you're more than welcome. All the material is also in those documents, but I'm not going to ask you how to implement it in the exam, but I will expect you to know what is used for, okay? Now, the next question is what the current solutions looks like, if any, okay? So, as I mentioned before, I'm asking all those questions to know what I'm going to do and to do it the best. So one thing I ask, what is it going to be used for? Second things, or in fact, it should be even first things, what are the situation today? How are you guys doing it today? How do you estimate the prices in a specific district? And here some people might tell you they're using manual and they have a board, they're deciding, and they don't, you know, they try to do some averages manually. And if they don't get a good answer or they don't have enough data, they try to estimate it in some rules. So you get the understanding of the problem. Secondly, they tell you that the estimation error is plus minus 10%. So you know that if your model will give you more accuracy than 10%, you're probably doing very good for this company, okay? So you're collecting data of the existing situation and you try to improve the existing situation. The 10% is a very good stick or benchmark, because if you don't give at least 10%, you wasted the money of the company, okay? So that's a very important, you need to, okay. Then, as we said, now I want to try to frame which kind of a study I'm going to do. They have told me I need to give them a specific number, not a category, okay? And they gave me a database. I will show the database, although I'm kind of jumping to get the data just to get a better sense. I'm going to go to chapter 2. By the way, all of that you have on your machine, exactly as I have it here, okay? So I just show you the data, and you see how fast and how beautiful it's jumped here. By the way, it's downloading the data from the internet and putting it on your computer, okay? Okay, this is the data set that I have. I look at the data set and I see the variables, okay? So just, it's good to see it even in this stage so you can really understand the problem even better, okay? So I just kind of jumped and I get back to that in a minute, okay? Now, is it a supervised study or is it unsupervised study? By the way, what am I trying to predict? I'm writing a model that tells me the median house value. So this is in fact the column, okay, that I already collected data. This is a sample of data that shows me for each district. Each row here, by the way, it is a different district. On the first district, the median house value is given. It's about $450,000, okay? Then I have a lot of data about the averages of income, how many bedrooms, blah, 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 in that specific district. But my dependent variable, the variable that I'm trying to study is the median house value is numeric. It is not categorical. Therefore, and it's given to me. So one thing I know by that it is numeric, that I'm going to use a regression type of algorithm, or a model, I should say. It's really almost synonym. So I'm going to use a regression. Second, okay, the second thing that I need to, is it a supervised or unsupervised, or is it semi-supervised, or is it a reinforcement learning? We said in the previous chapter that if I'm giving the data with the explained variable is given, it is a supervised learning. If I didn't have this column, and people try to tell me, can you divide all those districts to groups? That will be a classification study or classification model I should use, and therefore it will be unsupervised. But now I'm given the number, that probably should be a supervised learning, okay? So it's not unsupervised. Is it a reinforcement learning? Please go and see chapter 1. I talked about it last time. This is not a reinforcement learning. There's no agent, there's no actions I need to embed in this study, so it is not reinforcement learning. Okay, is it a classification test, regression, we talked about it, or something else? Okay, so you need to make your mind. Finally, pay attention. Should you use batch learning or online learning? If you go into chapter 1, what is a batch learning and what is online learning? In a batch, we take all the data, meaning we take all the data that we have and we train the model, okay? On the other hand, in an online model or online training process, every line that we take, we train the model, we improve the model for each line. So it's like, think about it, every time I get the data, I'm training the model, I'm improving the model. So I'm not going to take all the data at once. It's as information comes, I'm using it. In this case, since I have already all the data, it doesn't make sense to run one line by itself and then run the second one. We just use what is known as a batch study. So this one is a classical batch learning model that we need to use and not as online, because it's really irrelevant. By the way, you can think about it. What will be a good example for online? Think about Amazon. Amazon already passed that one, but let's say a startup that uploaded a system online, and then they try to improve their system as people use it. So every time somebody uses it, they get new information. And they take that information and improve their algorithm. So that will be a classical good online learning techniques instead of a batch. In this case, we have all the data. There's no point really to use online, but use a batch. By the way, I just summarized all the points here. I highlighted what I think it's a very important things for you to realize. One comment, I mentioned multi-variable regression. I don't know if you remember from your statistical course, when you have one variable that explain the other variable, like we did in the regression case, okay? Let me do this one so I can demonstrate in both chapters. That will be really cool to see how you can use this system in multiple screens and jump without having to jump too much. In this example, okay, hold it. I think it's this one. Yeah, in this one, we're trying that one, okay? This one, we have only life satisfaction that we try to understand how it's being affected by the GDP. I have only one variable in which I'm going to explain if people are happy in their district based on how much money the average GDP per capita. So we do see a positive relationship. The more money we have, the more people are happy, okay? But it's only one variable. If I'm using more than one variable, this regression analysis called a multivariant regression, okay? Multivariant regression. Okay, when I have more than one variable explaining what I'm trying to learn. That should have been taught in the statistics course, but I re-mentioned it here. Okay. The next element that we need to do, we talked about performance measure. I mentioned it last time, and we have it here again. What does that mean? Let me explain. It looks scary, but don't get scared. It's very simple. Let's take the simple example. We want to draw this line as close as possible to the other point. So our performance measure is to find a line that gives the distance of those points, all the points, to the line to the minimum. But in this algorithm, what we really do, we take the distance. Don't get confused and don't get scared. Forget about that one. Or what it says here, whatever you estimate the distance to real life number. What does that mean in the parentheses? In another word, it means, take the, let's say this point. What is this difference? I took the difference, I square it, okay? I take a square of it. So I take for this one, I take the difference and square it. I take the difference from this one to here, I square it. Then after I do it for all the points, I'm adding them up and divide by number of points. So I get the average square distance. That's what I'm getting, okay? And then I'm just getting a square root. So that's detail. It doesn't really make much difference, but it's common to do that. So I repeat, it's a performance measure. Why? It's give me the criteria how to find the best line. The best line is supposed to be the line that gives the distance from the line square to the minimum. That's really what this scary equations does. It takes every point, how far is it from the line on the chart, on the line, take the difference, square it, sum them all up. That's what it means here, sum, and take the average. After I took the average, okay, I'm just taking the square root. That's why it's called square root, or that's root mean square error. Error in the sense, why the people like to call it an error? It's really not an error, but people like to call it an error. It's really, if this point is in this distance, if somebody will come and ask me, what is the happiness of somebody that makes 20,000 a year? How happy he will be? I will tell him, my guess will be, I'll give him the number on the line. But in real life, that's the data that I have that's slightly different. But let's take another one. Let's say 28,000, okay? My guess will be this one. That's what I will say. That will be my answer on the line. But in real life, it is a little higher. So some people say the difference is an error. I wouldn't call it an error, okay? The error, it's really, I don't know. I know really where it came from, but think about it, not really the error. I'm just trying to minimize that all the points will be as close as to what I'm going to recommend. So if you want to call it an error, and that's what most of the people call it, so that's fine, as long as we understand it. Questions about it, and question about what does it mean performance measure. I will take a pause here. Anybody? Questions? Everybody clear? Everything's clear? Hello? Volunteer?
Yes,
It's
it's
clear
clear.
and good.
We are just on mute.
Oh, I'm on mute or you guys on mute?
No, we are.
I can hear you, by the way. Probably nobody else can hear you, but I can hear you.
Okay.
Okay, I do in fact hear you. Okay, I put it on mute. I think it's shutting on everybody so it doesn't disturb someone else. But I do
Yeah.
can hear everyone else. Okay, okay, good. A very important concept because, by the way, there is another way to, instead of the same equation, instead of taking the square and the square root, you take that's what is known. I will come back to this one in a second, but I just wanted to mention something else that is common also. It's called mean absolute error. If you look here, there is no square here. You just take the difference. That's why it's it's the absolute distance. That means in this example, I only take the difference between the point to the line. I do not square it, okay? I take only the absolute difference. So that will be the difference. It doesn't matter if it's up or below the line. Okay, I always take the distance. That's the meaning of what it says here. Those two lines means take the absolute distance of the estimate of the line from the real dot. Okay, sum them all up and take the average. That's what I mean. Add all the differences, add them up, and just take the average. Now, why people might like that one, by the way, pay attention that when I took the first method, the mean square error, it's if I have a point which is far away from the line, it will get a bigger weight because it takes that amount and you square it, it becomes to be even bigger number. So some people say, no, I don't want to put emphasis on point that they are far away from the line. Okay, so I will use the absolute. So every point will have its own weight, the same weight in the algorithm. So many people use that one. The most common one, believe it or not, it is this one for a good reason. And we will come back to that when we talk about outliers. If I have a point that, let's say I had a point right here, that point I should remove. I should really use it. Or definitely if I had a point right here, it can shift the whole line to be even upward. Because this one really makes it that I'm trying to take the line to be closer to it, I'm destroying everything else. Those ones, we usually call them outlier, so we just remove them, okay? So that's really an art to know which point I need to move, and we talk about it later on, okay? So both of them are performance measure, this one and the other one, and this is most common one in real life, but this one in many cases you will see that as well, okay? And there's many others. I'm not going to cover a lot of them, but those cover, like I would say, more than 90% of the cases. Now, this is more technical, and I don't know how much you know linear algebra, but let's say I get the data, let's go back to here. Our data is like that, correct? If you notice, each record here, it's a district. So we're organizing our data for each example. So many times, by the way, it's called a case. Some people call it a case, an object, an observation. All of those are synonyms to describe one line in my data, okay? So, and what we have done really, if you look at it, we already organized the data so every row, okay, will represent a case. That's more semantic. I'm not going to make you understand it or even know, but it's very important to understand if I have data about a specific district, some people might organize it as a column, and that's what I'm trying to explain, which is the market value of the housing or the median value of the houses in that district. So some people might put it that way, but we usually take this one, convert it to a row. So usually we have the data organized exactly the way I organize it here. We have, it's like a matrix that have that the dependent variable that we try to explain, and those are the other explanatory variables, okay? But each line here, each row here is a case. It's a district. And that's the way we usually want to organize data before we doing the analysis. Okay, this is just technical representations. And let's start. All of what we just did now is just really explain some concept. And now we're going to go through the process of doing our study. Stage number one, get the data, okay? In fact, there's a lot of sources of data, and the data we're going to use, it's from the Leap something that I put here is the website, okay? Fair enough. And in fact, what did I do the job of getting to this point? Whoever wants to go into the technical, and I strongly recommend, okay, you can go, you have chapter 2. Where is this chapter 2 come from? To remind you, I put it under the application called Core. I'm not going to spend too much time on technical issues. If you want, I will be more than happy to make special additional session on technical matters, okay? And that will be just enrichment. And I think it's very important. I will be more than happy to do that. But for now, it's just to understand all the code for chapter 2, it is in this file. And this file, it's under the core application, which is under the applications folder. This is the application folder, and it has several applications. The core, usually we put core code, and the code for preparing the objects for the chapter 2, it's right here. So here is just to inherit from the basic object, and here we prepare the data. Usually in these objects, we prepare the data as we did with chapter 1. Let me just open again chapter 1. We did the same things in chapter 1, okay? That's the only job that this one has to do, prepare the data, okay? I prepare the data, my data is ready. What does it mean? That means that this object will hold the data in a variable and call data. That's it. After that one works, I don't really care how we did it, okay? If I want to care, then I go and study all the code. But I really, as a manager, many times I don't really care. I will have my employee do it. I definitely like to know that because then I know exactly what my employee did. And if I find an error, I'll tell him, go and check that function. You probably did it wrong, okay? So, but this does the job, okay? So, in here, I'm getting the data, and the data, this function job is to put the data in the data place. Or in another word, now I want to go and understand the code that generated this one, okay? By the way, if you do it once, it becomes to be, you do it not once, you do it 5, 6 times, it becomes to be really easy. You open this file. Where is this file sits? I close the code. I don't really care about the code. I can't even close it, okay? I'm going to, this is important file, and everything says is right there. I won't really kill you with this one, and I really want to focus on not even this one, and I want to focus on the intro to machine learning. That's the most important application for us for this course, and this file has all the code, literally all the code. Some of the presentation are in the templates, but we'll get to that later on to some extent. Okay, so let's see, if I do double click, it's really opening this file. And this file is well organized. It's every chapter, it's separated by those lines. So I'm done with chapter 1. I can, this is a huge function, not this one, this one. It's a huge function. I don't really care. I close it. I'm not going to bother myself. I want to focus on the code for chapter 2. So the code for chapter 2 is well organized here. First things that it does, it creates the object. By running this one, and I demonstrated last time in other sessions, that this one prepare the data for me. When the data is prepared, let me close those ones. When the data is prepared, this one show me the data. By the way, a lot of the stuff that I put here is just for you. The bottom line, this is the only things important. If you notice, all what it does is defining a new variable. I really didn't have to, but I wanted it for your education, whoever wants to follow and learn a little bit about Python code. I'm just taking the same data. All my data is here. This is a data frame. By the way, I could erase everything's here, by the way, and work just fine. I can erase everything's here. This is just making a lot of comments. Delete it, and wherever it says housing here, okay, when you see here housing, I can just put this one right here, and it will work. Okay, the same things, just more readable. This one for you, so you can see the output. Let me run it. Let me close the whole thing. Rerun it, so you know how to study if you really want to learn how the code works. This type of code, I do think you should spend some time. I'm opening the application. I'm going to chapter 2, and I'm going to choose get data. I got it here. Okay, I want to see some information here, by the way. And you will see the rest. We're going to go over it. So why did I restart the whole thing? Because this is the beginning. And I did Control-C. I shut it down. I ran that command, and it started cooking. Start cooking. When I clicked on get data, it generated all that stuff. And how do you know that? By the way, if you look at the code here, okay, I got the object, I put the variable here, and I made lines. If you see, those are the lines, 10 lines. This is right here. Fair enough? This one, by the way, in the constructor, so I don't see it here. Then I get 10 dashes. Then I write a little title, by the way. Do you see that? That's exactly what it says here. I'm just printing this one for me, so when I see that, I know what I'm getting. And then I'm printing really just to see the data here instead of seeing it here. Here is another way to see the same data, but programmers and real professional people in this field, many times before they get to the point of presentation, they're doing all this hard work, and they usually like to print it for themselves. So this is the way you can print it to yourself. You take the data frame, and then we learn the function head means show me 20 rows. Okay, so here we go. We're really seeing 20 rows. This is just that. So I'm as a programmer, okay, good. It looks good to me. What the next I want to do? I want to get some statistics about it. And in a minute, I'm going to talk about this one. So you can see the same data here, by the way. This is a function info, and I'm just printing it. So I'm running the function info, and I see the data right in here. Another way to see that is just simply going to this one, by the way, I'm just going ahead of myself, okay? And there's, in fact, this one I didn't put here, I don't know why, but in the chapter is right there. If I, let me close some of them. Let me close this one. Okay, if we go here, you will see after we plot the data, we run the info. Yeah, I know why, I was lazy. Okay, so This one, it shows me the information. By the way, seeing it here, this is exactly what a programmer that's working on the case, his brain is thinking and analyzing the data, okay? So he can see the data here. By the way, I want to attract your attention. This function is very important one. It's called info. Give me informations about every column. Okay, what the information that you want? And the main information is how many data do I have in every column. So for the first one, I have 20,640. Same for all of them. And then I'm getting to total bedrooms. I'm getting 2,433. What does that mean? Anybody wants to guess? Anybody? Anybody wants to guess what is 2,433? Hello? Did I lose you guys? I volunteer to say yes or no.
I'm not sure.
I'm thinking, not sure also what it is.
Okay, this info command basically counting how many data points you have in that column. Let me explain that clearer, okay? Look at the data, let's look at the data. We have the data, we have columns, is that right?
Yeah.
And I said to him, for each column here, tell me how many data points do you have, okay? So he went and he looked in all the columns and he counted all of them. So for the longitude, okay, let's look at longitude. What is longitude? Here we go. He counted how many numbers there are and he found that there are 20,640. And he did it for the next one, next one, next one. All of them has the same number of data, but this one, he found less number. What does that mean?
That there is less bedrooms.
Correctly. There might be some districts that don't have data on them. So in another word, this command kind of helped me out to find if there are some columns that have some missing data. So total bedrooms has a missing data. How can I know? Because all the other one has the same number, but this one. So I'm missing data for total bedrooms. So what am I going to do? That we will talk later on. But at least the info command is something I do require, you know, in a data frame. There is a command, a function called info, and this info gives me an information about how many data points I have in that column, and if some one of them has less, then I know that this column has a missing data. Okay? Good. So that's the objective of the info function. What do we do with those missing data? We'll talk about it. In fact, how many are missing? It's simply 20,640 minus the amount we see here, 2,433. That means I am missing 207 data of total bedrooms. So what am I going to do with those? Should I erase those rows because I can't use them? I'm missing data, or fill them up with something. So we will get to that, okay? But at least the info functions help me to find out if I have all the data for every column. What we use the info function for in a data frame?
But to count
count.
data per category.
Correct. We count how many data points we have in every field, in every column. Beautiful. And if we see some of the columns, or one of the columns in this case, have less data point, that means we have
Like
some
the
rows,
bedroom.
exactly, that we don't have data for them. We can
Yeah.
find them, by the way, there are commands that can bring those ones immediately and show me which rows they are, okay? And that's what usually people do in real life. And then you ask yourself, well, how I am going to fill them up? Or am I going just, you know, I have already 20,433 that are all filled. Maybe I can ignore those 207. On the other hand, somebody says, you know, Don't ignore those, because there might be a reason why they are missing. And maybe they have information that I don't want to lose. So I want to keep them, but I need to fill those data with something. And that's what's called imputation. We impute data into a missing data. Okay, and we'll get to that. I will mention the simplest method. I will mention complex method, which I'm not requiring you to do. I usually use very complex method called mice, and but I'm not asking you to use it. We will use a very simple one of a mean, and I will demonstrate. Okay, and other things, let's go into the data. If you notice, I see numbers here, numbers. What's special about this column? Anybody?
It's text.
Exactly. And you see it's repeating?
Same, yeah.
It's repeating itself. So which kind of data is it? Is it numerical data or maybe categorical data? What do you think?
Categorical, or if it's repeating.
Exactly. This is really most likely that all those districts belong to the same area, maybe nearby. So maybe somebody tried to group all the districts to different categories. So I would like to know which kind of categories exist. Here I didn't really print all of them, so I only see the nearby, because it will take a lot of time just to see it, and I'm not going to scroll 20,000 or more than 20,000, almost 21,000 of data. So what I can do, I can run a command that call, the housing is my data frame. And in the previous sessions, when we studied Python, if I don't want the whole data set, I only want one column. This is the way I get that specific column. And the column that I'm interested in is the ocean proximity, okay? So I'm going to pick only this column. I'm interested only in this column. The way in data frame I pulled it out, I just used the name of the data frame, which is housing, and then inside a square bracket, I'm putting the name of the column, and that column is ocean proximity. Okay, how close I am to the ocean. Okay, now that I picked, this is like I have only one column. I forget about all the other columns. And there is another command which is really useful in data science, values count. It counts how many values I have of each value. In another word, if I look at this data, how many rows I have for nearby. So it's going to take all the type of categories, and for each category is going to count how many rows I have for that category and give me a report. And that's what we're getting right here. This report we're getting by this command. Value count on a specific column will tell me which kind of categories I have in that column and how many rows I have for each one of them. By the way, if we go here, right, if you scroll down, we're getting it right here. Okay, how did I get that data? Very simple. If you want to know, you just go down here and you scroll down. You see, we went over the housing info. We saw the printout down here. I can go down and look at the next comment, which is exactly what I showed in the text. This is exactly the comment. Is that right? The bracket is around is just to print it, okay? So this one is printing the results in this way. I was a little more sophisticated. I also know how to take the same information presenting on a website. The job of this part is beyond the scope of this course. It's really a different course. I just gave it to you so you can see it's nicer on the screen, okay? But basically, this one is really, I'm creating the housing and I'm counting and I'm getting the report right down here. A real programmer, when he's working the first time before he gets to present everything, he does it this way, and later on spend the time on how to present it to everyone else. That's why I said it's beyond the scope of this course. But it really should be part of this course because we need to present it as the last part, the one before last step of machine learning study. Okay, now we learned another command called value count. It counts how many rows we have in each category. We usually do it on a variables that seems like a category. And this one, it's very easy to see. And we can see nearby, we have the 2,290. How many islands? Only 5. Inland, 6,551, blah, blah, blah. So we have 5 categories, basically. Okay, this is the smallest, probably there are a few islands, but not too many. And the rest are different kinds, okay? So we might be interested really on knowing something about those districts, on the areas, or let's call them areas. I might want to do some analysis on those areas, but for now, it's just really to learn about the data. We're doing kind of getting the data, understand those data. Okay, there's another command which is very useful. It's getting some statistics about every column, okay? Let me make this one a little bigger. It seems like a little smaller. By the way, this is the beauty about this system. It seems to me a little smaller, so I can just go here and I will increase so you can see the picture a little bit. Let me make it 1100. So I will be a bigger picture. Yeah, this looks better, isn't it? What did I do? No, I didn't do it. Was it this or this? I forgot already. Is this the one I just changed? I think so, isn't it? I'll do the other one. It'll take a second. But that's good. We need the other one also to be as big. I'll do this one. But I think this is probably lower. Yeah, this is this one. Let me do the same things on this one. Check that one to 1500. That should be better. We'll see a bigger picture. By the way, if you go to Academy City, it's bigger now too. So it's done. Okay, let's scroll down and here we go. We have here, we can see it's much better here. Okay, we have a command that can help us to see some descriptions of the data. So the command describe does automatically goes for every column here and get the statistics, okay? So what do we see in the statistics? We can see how many, by the way, this number we already seen, okay? We have 2,640. So we can really see here that we have missing data. Secondly, we see the mean, okay, of every variable. Then we see standard deviation, okay? Standard deviation is very important, by the way. What is the standard deviation for the housing prices? It's 189. You know, it's 1 million, by the way. Sorry, this is the median. This is the median income. Sorry about that. Household. Now, where is the? Yeah, here we go. The last one. The last one is the standard deviation. So I can say standard deviation of $206,000. That means that the pricing in California, I would say it's very diverse. Wouldn't you say that? Anybody? If I tell you the standard deviation of prices between districts is $206,000, that's pretty, almost $207,000. What do you say? Is that big or small? Anybody?
It's a big number. So
It is a very big standard deviation.
for standard deviation, yeah.
That means that in California, housing can go really from very poor areas to a very extremely rich one. Is that right?
Yeah.
Another now, that's immediately, this is really something I already can say. That means my challenge of prediction might be even higher because there is a big standard deviation, okay? Okay? Sorry, I made a mistake, by the way. It's not, this was the mean. I mean,
Yeah, but also
but
high.
this one also very high, 115 is also very high. Okay, I really should refer to the 115. Okay, the mean is 206. What does mean? Mean is average. Let's look at another number, which is very important, that's called median. 50% is the median. Let's look at the median, by the way. How much is the median? 179, almost 180,000, almost 180,000. On the other hand, when I look at the average, it's 207. 207, which is the average, it's higher, quite substantially, I would say, from the median. Do you agree? 207, it's almost 15% higher than 180. Let's say about at least 10%, more than 10%, I would say. 10%, about 10%, 10, 11%. What do you say when you see the mean is higher than the median? What does it tell you? Now we're going to the statistic course. Anybody? If I tell you, let's say let's look at an income. You have a country that the average salary, it's much higher than the median. What does it mean, median? Median, it's the middle person. If I take all the people, or I take all the houses and organize them from the cheapest house to the most expensive house, what is the one in the middle? That's a median. But if I take the average, taking all them and divide by the number, what does it mean when the average is higher than the median?
That means that there is more high value houses than.
Beautiful. Inequality. That means I have more houses expensive than cheap ones. So probably in California, there are more rich people than poor in a sense, as far as housing prices are. So this is already telling me something also about, and I'm not talking about a regular distribution that it's going like smoothly. The houses, there's more expensive houses than cheap houses because the average is above the median, okay? And then amazingly, and we get here the max, we get 501,000. I don't believe that number. I know that that number cannot be. The highest price of a house in California cannot be $500,000. Is that right?
Yeah.
Can you see all those movie stars living in a house of $500,000?
No.
I don't. So that's
I-
already raising an
I-
eyebrow. Exactly. That's already, see, on that simple, I just ran something so simple as immediately struck my eyes about this data. I need to be cautious when I'm going to analyze it. I don't believe in California, the maximum price is $500,000. Can't be. So in a minute, we'll come to that point, okay? But see how much I learned from such a simple command. And if you go and look at the code is so simple. And whoever wrote all those libraries did a beautiful job. All what I had to do is take the data frame, which is the housing, to remind you the housing is what I already created when I created the object. I didn't really care how it's done. For me, the housing is everything. I forgot about how it got there. Now I'm analyzing the data, and all the analysis goes to the same data frame. And I use info. I use house counting for specific column. I'm using now another command called describe. I'm describing the data, and that's giving me a beautiful understanding, at least the data. So when I'm getting the data, I'm looking at it, not ignoring it, and try to make sense of it. Fair enough so far? This is a good one. Let's move on. What is better than seeing something? I think the best things to do, I want to see the distributions of those variables. You know, I got the data, I want to get a sense to it. And getting the sense, there's nothing better. By the way, we finished that one, you just go to the next one. And the next one is plot attributes. Again, who wants to help me? Here we go. I got all these. By the way, the nice things here, you can just increasing it. By the way, I took the pictures from here and put it on the text, but I can't really see the pictures as good as you can see it here. It's the same picture. Where do I find the code? Anybody wants to help me? Okay, I will go there and somebody jump and tell me. Where should I go here to find? I'm finished with this one, is that right? I'm moving to the next click. Is that right? I have another click. And if I click here, this is the code. This is giving me the code, the whole code about creating. See how simple it is. Amazing. The truth of the matter is so simple. The whole job is done here. This is just does histogram. By the way, if you remember, I called algo data housing. It's the same things. So I was lazy here and I didn't really want to waste my time. Just like going directly to the data frame. And the only command I had to give is hist. Hist is for histogram. Make me the whole histograms, okay? Here I just gave him the size of the histogram, so it's going to be big or small. Beans means how many lines to report for, but that's detail. The key point is to know that there is a command in data frame of pandas to plot histogram. So that's the whole thing. The rest is really, if you see, this is saving the image, I'm plotting it. This one, as I mentioned, this is saving it, and then I'm just showing the picture. This one is showing. But the real function is the histogram. Okay, so let's look at that. I'm looking at the histogram. Wow, that's interesting. Anybody wants to comment about housing median age? Let's look at the first one. How about the housing value? Here we go, the median housing value. Anybody wants to make a comment? And something I mentioned before about movie star living in a house of $500,000. What do you think about this picture? Anybody? Is something strike you immediately? Is that a normal distribution?
No, it's not.
Good, thank you. Just somebody
Because
answer
between-
something, it doesn't matter, so I know I didn't lose the contact.
Between
Right.
4 to 500,000, there's like a low, and then there's a spike at
Exactly.
500.
You see there is a huge line. There's so many people have exactly $500,000. Doesn't make any sense. Okay? That's most likely somebody said, you know, I want to focus only in this range. And anybody that has a house more than $500,000, I would just mark it in my database as if he has a $500,000. That's a very dangerous thing to find out in your data, because this is really destroying your data in a sense. No question, there's a lot of people that have a house more than $500,000, and all of those, I'm telling, they are only $500,000. We tackled that issue later on. And the question is, should I remove it? Should I go back to the person, provide me the data and said, listen, I know you're doing a good job, but please don't do it. I need the specific data also for the expensive houses. I need for every house, don't cap the data on $500,000. It might destroy my data. Or I will say, I go to my boss and I said to him, listen, the data of $500,000 and above doesn't exist for me because somebody kept the data. So I'm going to focus my data analysis or forecast only the range from 0 or close to 0 to up $500,000. And I'm going to ignore trying to predict prices above $500,000. And then I will remove all those lines or those rows that have $500,000. This is a common known problem when you're getting a data. That's why, you know, if we didn't plot it, you didn't really see it in the describe command. You know, we just got the average and all that. But we did really got the signal, but we know California. If I did it in Oklahoma, some small city there, most likely I would say, well, I might don't find, maybe very few have a $500,000. But if I'm talking about California, talking about Los Angeles, Beverly Hills specifically, I doubt the houses there $500,000, okay? So that's immediately raise the question, but when I look at the image, it's immediately telling me there is a problem here. That's definitely not a a normal distribution, and that's a problem I must handle in some way, okay? Some things we're getting when we deal with housing median age, okay? Somebody kept it that if the houses are older than 50 years, it chopped it off. So I'm dealing really with housing below 50 years. And this is above 50 years, I cannot say anything. So the same issue raised here. I need to go back and ask for data. For now, we cannot really go back, so we'll have to handle it. We might just remove them, okay? Or just, and most likely we'll remove them. We'll get back to that and we'll make a decision there. And other things, if you notice, when you look at data, which is common in data, ignore this part, you notice that most of the data are here, and then you're getting a little sloping down. This kind of a chart called heavy tail in the machine learning vocabulary. Why is it a heavy tail? Because it's as dragged, you always have also very high values. Some things we can see here. We have the majority, up to this point, you could say, if it ended up like here, you could say it's, you know, it's kind of almost a normal distribution. But here we have many kind of little ones. By the way, here we have the same phenomena. Somebody kept the data for above 15, so we will ignore this one. But even though most of the data, and very common when you look at a lot of data, they usually have a heavy tail. And that's what it means, heavy tail, okay? Some things here it's almost all of them has that. One way, I won't get into that in this course, one way to handle heavy tail, it's converting the data to taking the log of the data. So in here, I will take the log, okay, of the median house. So instead of using the median house value, I will take the log. What the log does, it takes bigger numbers and shrink them more than it does for smaller numbers. And thereby, it takes the heavy tail and make it more closer to normal distribution. So one way to handle heavy tail is just taking the variable and take a log. Not always, but many times it's a good trick to do. So we talked about this one. I have couple minutes more. I'll just say no questions that, what is this one, by the way? I will pose it as a question. What do you think? Think about it at home and I'll put it as a, take a test. We have a latitude, and in the latitude, we see two groups. One is here and one in here. Anybody wants to guess? I would put that question also in the take a test. What do you think? What does that mean? Latitude is really going from east to west. Is that right? When I get a chart like that, what does that mean? You know, when I go in California from east to west, what am I seeing in the mirror? I see that there is a lot of people live in these districts around this area. You know, if I look at the chart, let me jump ahead and we'll conclude the session for today. If you look at the chart, you see you see this one? A lot of people living here around here and a lot of people living next to the shore. So when I go east to west, okay, I get a lot of houses in this range and in this range. So what this chart means is, not this one, so I go back to this one. When I look at this one, that means I have a lot of people living in this area to the east, and those ones probably too close to the ocean, okay? So I have two groups, some in the middle of California, some close to the ocean. And that's really, unless you really know how to read those charts, many times you miss. And that's really why charts are a beautiful tool for okay, we are done. Questions, guys, before I conclude the session?
No,
No.
Yeah, everybody happy?
very.
Thank you, Amos.
Thank you, guys. Please watch the videos, go over that stuff. I will upload a take a test. Please do take a test. It's a good preparation for the exam, okay? Because the questions there, I won't put them the same way because I'm writing the take a test, so I'm also training you to learn by the take a test. But in the exam, I will take very similar, just rephrase it differently. So take a test is very important. Read the chapters and good luck. See you next week.
Vamos, thank you.
Thank you,
Amos?
guys.
Bye.
Bye-bye.
I have a question. I had an idea about a project for a business development. When I was working in a venture capital last year, we were doing a lot of business development because I was also working with the accelerator. And basically what we were doing a lot of the day was going on LinkedIn and searching for people, then copying the link, putting it on on the Excel table, copying the name, Excel table, where they work, what do they do, etc., etc. And I wanted to know, like I was thinking, can we automate that with a machine learning program maybe?
Definitely. The truth of the matter, what you just said now, all the process you talked about, it's the first stage before it's preparing the data. It's processing the data. Machine learning designed to analyze the data later on. Okay, taking the data, all those links, and putting it in Excel. Instead of putting it in Excel, you can put it in Excel, okay, and then you upload it to a data frame, and in data frame, use what we just started today, visualize the data. For example, if you have the data and you have also zip code of the people, you can already have a nice chart showing you how many customers you have in any different area code. Which could be, that's part of the visualization. Okay, so that's a beautiful project. If you want, you're more than welcome. I will be more than happy even to help you. That's a beautiful project, and I will be very happy to help you. By the way, where do you pull the data from?
So I was thinking of like pulling the data. So usually what we do is we research in a specific, we go on LinkedIn and we search for specific keywords. And then from the list we get, we click on every single, like it can be a list of 3,000 people we get. And we click on everyone and we check if they're really relevant or not. And my idea was to basically first use maybe an API that LinkedIn will provide to access the data of LinkedIn, to use their filters to see the connections, to see the people, and then instead of having to go through LinkedIn doing it, automatically the API will gather the data, and then the machine learning program or the algorithm will just clean the data and putting it nicely. Or I said in Excel because I'm always working on an Excel, but like, or as you did it like on your website, you know, clearly with a nice table. Yeah, basically that was the idea.
Rafael, I wanted to say two things. This is a beautiful project, and it's in my first point. And the tools, it's called, you know, scraping the web.
Yeah.
Or the right way to do it's what you just said. Going to the API and see if they have an API. So you don't have to click even the first one to get the 3,000. Definitely, after you get the list of 3,000, you can take the link on the top. You have the link, and you can, with Python, connect to that link and try to take the segment of the web page that have the whole list and write a loop that goes one by one, bingo, and download the whole things in one time into a different, into Excel or into a data frame, right, directly. And thereby you don't even have to save it on an Excel. Better way even, just put it inside the database, directly into a database. And then after you have it in the database, you pull, every time you want to analyze the data, you just pull the data from the database. You don't have to go to online anymore and just start looking at and analyzing. That's the right way to do. My second point, and I'm recording it because I wish somebody would hear it, okay? I already said many times in the past that it's a crime to teach you Excel too much. It's good that you know Excel. You should know Excel. You should know how to use it as preparing basic data. But since it has so many other capabilities, people tend to use it more than they should. Because that's the only things they know.
True.
But then just imagine clicking 3,000 links. It's ridiculous. It's literally ridiculous. You should use a tool like Python or a programming language. Doesn't matter, Python, whatever, R, whatever tool, they're all excellent. By the way, I'm using Python for my own reasons, but I'm expert on R, I'm expert on C#. All of them are excellent programs. You know, I won't say one is better than another one. All of them do excellent job, especially on the projects you mentioned, okay? I use Python because I think it's the mainstream today. And it's sponsored by Google and by Stanford University. So this is a good reason to go. If you don't know anything, Python it should be your first check to see if that fits you. But if you don't know any other language, if you do know already other language, and that's the only things you want to do, go just with that language. Probably you can do everything with that one. Okay? So you're more than welcome. I think this is a good project.
Thank you, Amos. And
Have
also
a good one. See you next week.
a little other thing also, Amos.
No problem. Go ahead.
So that was one of the projects. The other one is linked to the first homework you gave us in company evaluation. I'm in the finance track and not in the
That's
digital
right.
track. And so when I was doing it, you know, during the process of the years at ADC, we have been doing this analysis, a SWOT analysis, the overview, everything. How many times we did it, I can't even tell you how many times we did it. And I was thinking, why do we have to pass through the steps all the time? Like, this could be a machine thing to do, you know? Like, I was thinking.
Did you like my corporate valuation class?
I love it. I love it. I'm always
How
lost.
about the simulation? The simulation is just like a miracle. It looks like a magic.
I'm always lost.
It's,
I'm trying to.
by the
I'm
way,
trying to
the
follow. I
hardest
have to
course,
go back.
it's the hardest course in finance courses. And the simulation, I don't think anyone in the world has that kind of a simulation, because pulling the data.
It's a really interesting database. Yeah, it's true. I went over it. I saw the database and everything. It's really amazing. Like all the jobs, the EBITDA, you have everything written there. It's really like, wow.
Yeah. So what do you want to do on that one for this project?
So the second project I had in my head was to do, like, you know, like when we do an overview, for example, for a company, we search for the latest, like the 2 latest article on that company to see if something happened recently. We search on the company website to see a bit what they say about themselves, and then some newspapers that are always saying things about the companies. And so this is, for example, to write the overview. I would have wanted to build but this is like a big, I think, NLP programming, but to build software that will basically you can bring your links. You bring, like, for example, 5 links. You give it to the software.
I love it. You know, I mean, even, you know, you're ahead of me because my time was limited. I'm going to add a lot of stuff to the corporate valuation. Remember the first assignment I gave you to do SWOT analysis?
Yeah, of course.
What
exactly.
I'm going to do, I'm going to add another folder, okay, information about the company. And then when you click on it, you get many links, you get articles, you get a link to the website, you know, and then everything is ready for you. You want to read about the company, you chose the company, bingo. Instead, next to the data, it will be, you know, there will be info about the company, and then you're getting all that information nicely. If you want to work on that, you're more than welcome. That's a beautiful. I like your second project even more than the first.
Yeah, I also like the second one even more because it's easier to do, and it's really
very beneficial. Very beneficial.
Thank you.
Have a good one, Rafael.
Have a good one, Lee.
You too.